Hello and welcome to 8.2. This section covers length, area, and volume. However, our discussions on problem sets will be over only area and volume. To get started, the important thing you're going to want to learn from this are the area formulas, particularly for squares and circles. And here is the formula for the area of a circle. And for the area of a square, you just want to know that the length times the width is the area. So let's get started with some examples of that. So find the area of the problems. For number one, find the area of the figure in centimeters. So, area is length times width. In this case, this is going to be width and this is going to be length. So A equals the length of 10 centimeters times the width, which is 4 centimeters. And when we multiply these together, A equals 40 centimeters squared. Notice it's squared because we multiplied 2 centimeters together. All area will be measured in units squared. With area of number 2, we know length and we know width. So A equals L times W. So A equals 100 centimeters times the width of 1 centimeter. So A equals the area of 100 centimeters squared. With this next example, we have a round table. And I believe we can actually draw a circle. So with this circle, we have a diameter of 49 centimeters. Okay, and for this we need to know what the radius is actually. And how do we calculate the radius? We have the diameter, and we divide it by 2. So we have 49 divided by 2. So the radius is 24.5 centimeters. Okay, now let's use our formula that we learned on the first slide, which was the area for a circle is A equals pi radius squared. So A equals pi, which we usually like to say 3.14, times the radius of 24.5 centimeters squared. So if you punch that out on your calculator, you should get an area of 1,884.785 centimeters squared. Notice that we squared this term, so that's where we get the centimeter squared. Okay, looking into the area problems, we have a swimming pool which will be 18 meters long, 9 meters wide, and has a uniform depth of 3 meters. Find the volume of the pool in cubic meters and volume of the water in the pool in kilometers. So to do that, I want to first start by documenting the length, which we said, or the problem said that was 18 meters. We know that the width is 9 meters, and we know that the unified depth is 3 meters. And to use our volume formula, because it's a rectangular prism, we use V as L times W times H. And we're going to plug in our values for V equals the length of 18 meters times the width of 9 meters times the height, or the depth, that we can call it 3 meters. So V is going to equal, if we multiply these together, we're going to have meters cubed. all volumes in meters cubed, and that is going to be 486 meters cubed. And since the pool holds 486 meters cubed volume-wise, and 1 meter cubed equals 1 kilometer, the pool can hold 484 kiloliters of water. So this basically means the same. So basically what I just said equates to this. This is the kilometers worth in the pool. Okay, and the last problem before we get into the next section has a hot water heater, I should say heater, in the shape of a right circular cylinder. It has this radius of 40 centimeters and a height of 148 centimeters. What is the capacity in liters of hot water heater? Okay, so our radius for this is going to be 40 centimeters, with the height being 148 centimeters. Okay, now let's use our ability to convert our centimeters to meters. Okay, so the radius was 40 centimeters, so that means the radius has to be 0.4 meters. The height was 148 centimeters, so we can find the meters to be 1.48 meters. Now let's use our formula for finding the volume. So V equals pi r squared times h. So let's plug in our values. V equals pi times 0.4 meters squared times the height of 1.48 meters. This is going to be meters squared here times meters, giving you the volume being meters cubed. So we multiply all that across, it looks like we're going to have a volume of 0.743552. Okay, and now we use our conversions to convert cubic meters to liters. And for that we need to know that 1 cubic meter is equal to 100 liters. Excuse me, 1,000 liters. So we place what we found to be the volume of 0.743552 times 1,000. We should get the capacity of 743.552 liters.